Quadratic application problems. Okay. So early on, I think one of the key feature pages, we were talking about what quadratics can be modeled as. So more often than not, and they can be modeled as numerous things, but a lot of the time it's used to model objects in flight. Objects in flight. Like, so, if I were to have just kind of sketch a graph here, if I were kind of, and this is just a random example. If say this is the height of something, and this is time, it usually starts off at some height. It could start on the ground or off a launch pad or something, and it's going to fly up in the air, and then it's going to hit the ground. So its height is going to increase over time, and then of course gravity is going to drag it back down, and eventually it'll hit a height of 0, which is the ground. So just keep that in mind. Hopefully that's not too hard for you to visualize. I mean, you can throw something in the air and see it kind of holds a parabolic shape. Okay, so a couple of these bullet points. So the initial height, which I would kind of show like a red dot right here, that is referring to the y-intercept, right? The initial height is referring to the y-intercept. The maximum height, that, like this blue dot here, that's talking about the vertex, right? That's the vertex of a parabola. And then it says the time it takes for the object to hit the ground is referring to the roots or the zeros, the x-intercepts, like this spot. Like that's what that's referring to. So keep that all in mind. Maybe I'll underline these just to relate it to that graph. Okay, so initial height is your y-intercept, maximum height is your vertex, and the time it takes to hit the ground is talking about your x-intercepts. And if you can't recognize that, then you're going to struggle with these problems a little bit. You need to know what it's asking. So here we go. Number 1, it says a squirrel jumped off a tree branch onto the ground below. The height h of t of the squirrel in feet after time t in seconds is given by the equation h of t equals negative 16t squared plus 15t plus 18. Find the following information. Round to the hundredths place when applicable. So a lot of these problems here, we're not going to have exact answers, right? That'd be very rare for it to be an exact answer. So we're going to have to do some rounding. Some decimals are going to come into play here. Okay. So A says, how high up the tree was the squirrel when it initially jumped? So what is that referring to? It's referring to the y-intercept, right? It's referring to the y-intercept. This squirrel was on some tree up high and then jumped and then got some air and then landed there, right? Initial spots referring to the y-intercept. And remember, when it's in standard form, the y-intercept is 18 feet. Remember, you can plug in 0, right? To the y-intercept is when the x value is 0. But if you plugged in 0, it's kind of a waste of time because 0 squared is 0, negative 16 times 0, that would just be 0. 15 times 0 is just 0. So it's just 18. Okay. So that's the initial height of the squirrel when it jumped. Easy. That question is easy. What's the squirrel's maximum height? Now this you got to think a little bit. The squirrel's maximum height is referring to the vertex. Well, I'm going to write vertex underneath this. We need to know the vertex. But remember, before you can ever get the vertex, you first need to know the axis of symmetry. Because to get that vertex, to get that maximum height, you need to first know at what time it reaches that maximum height. So like if this is our height, we need to know at what time it reaches that height. So we need to find our axis of symmetry first. Remember, to always get the vertex, you first have to find the axis of symmetry. So let's do that. So I'm just going to label this AOS for axis of symmetry. And remember, the formula is negative b over 2a. So I've got x equals negative 15 over 2 times a, and a is negative 16. 2 times negative 16 is negative 32. And this is where it's going to get messy, because we're going to get decimals. negative 15 divided by negative 32, I got 0. And I'm going to round to the hundredths, kind of like it said here. I'm going to round here 0.47. So it's about 0.47. So I'm going to draw a little squigglies because it's approximately that. So that's the axis of symmetry. That's the time at which the squirrel reaches max height. And that kind of makes sense, right? I mean, the squirrel like jumps and half a second later he hits his maximum height. It's like the squirrel doesn't have that big of hops, right? He ain't going to jump like he's not going to like jump really high, right? He's just going to do a little jump and have half second later, 0.47 seconds later, he's going to reach his maximum height and then he's going to come back down. But we got to figure out now what his maximum height is. We got to figure out how high he gets in the air. So we're going to substitute the 0.47 in for x. And technically I should have used t, shouldn't I? Because it's not an x variable, it's a t. I'm going to make that a t. It's not a big deal, but I'm going to make that a t. So now I'm going to plug in 0.47 to the equation for t to get what that height was. So I'm trying to find, and I'll use function notation. I'm trying to find the height at 0.47 seconds. So substituting that in there. Okay. All right, I'm going to do a little bit of this at the same time. So 0.47, squared, and then I'm going to times it by negative 16 all in one step here. So 0.47 squared, and I'm just going to leave that in my calculator, times it by 16 negative. I got negative 3.5344. I'll hold off on rounding there. 15 times 0.047. Oh, dang it. No, 15 times 0.47. I typed that in wrong again. 15 times 0.47 is 7.05 plus 18. Add those all up. 3.5344 plus 7.05 plus 18. I got 21. And I'll round here, 21.52. So the vertex, if we were to write out the vertex, I would write 0.47, comma, 21.52. But it's a word problem. It's not really asking that. It's saying, what is the squirrel's maximum height? It's 21.52 feet. It's not asking for what time it reached its maximum height. It's asking what is that maximum? So it's asking for the height. So like this point up here in my little terrible sketch graph, 0.47, comma 21.52. That the 21.52 is the height. The 0.47 is the time it took for the squirrel to reach that height. Okay, that can be a little confusing. Okay, C says after how many seconds did the squirrel hit the floor? Well, I guess more like the ground, the floor, or whatever. So that's referring to the x-intercept down here when it hits the bottom. So that's when the height is 0. So I'm going to say 0 equals negative 16t squared plus 15t plus 18, right? That was the equation? Yeah. So I'm looking for the x-intercept, the height when it's 0. I'm trying to figure out what time after how many seconds. So now I got to solve for t. And this doesn't look factorable at all. So I'm going to use the quadratic formula to solve this equation. So this might get a little messy, as a lot of these word problems do. So remember the formula is x equals negative b plus or minus, square root b squared minus square root of b squared minus 4ac over 2a. So I'm gonna write t instead because it just doesn't have an x. This equation is a t, right? So negative b, so negative 15 plus or minus the square root of b squared, so 15 squared minus 4. A is negative 16. C is 18 over 2a. That's the setup. Time to simplify. So that'd be negative 15 plus or minus, okay, 15 squared is 225 negative 4 times negative 16, that's 64, right? And then times 18, geez, this number's going to be big. Woo, okay. Positive 1152. 2 times negative 16 is negative 32. All right, moving along here. 225 plus 1,152. Hopefully I don't make a mistake as I'm doing this. So, I advise you when you're doing these on your own to go a little slower than I am, because very much prone to mistakes when you go quickly. Now, the square root of 1,377, like, that's not a perfect square. Like, you can type it in, it's not a perfect square. So you might be thinking, oh, we just leave it like this. No. This is a word problem. So we're going to be estimating getting decimals. So we're actually going to go ahead and we're going to take the square root of 1,377 and see what that is. So if I do that, I type that in, I got 37.107. So I'm going to round here. Okay. I'm going to keep working up this way. So negative 15 plus or minus, I got them in a round, 37 and it did say the hundredths, so I'm going to say 37.1. That 0 rounds up to a 1 because of the 7 after it, over negative 32. Whew, okay, keep it going. So here we go. Now we can break it up into two separate pieces. We got negative 15 plus 37.11 divided by negative 32, and negative 15 minus 37.11 divided by negative 32. So let's do that. So I'm gonna bring the t back in here. T equals negative 15 plus 37.11 divided by negative 32. And t equals negative 15 minus 37 and 11 hundredths over negative 32. And let's go ahead and get these. So 15 negative. I'm going to type this all in at once. Negative 15 plus 37.11 equals, I got 22.11, divided by 32 negative equals, so I'm going to round, I got negative 0.69. And we'll talk about the reasonableness of these solutions in a second. But let me just get the other one now. Again, I'm typing this all in at once. 15 negative minus 37.11. I got negative 52.11. Divided by 32 negative is, if I'm rounding, 1.63. Okay. Now, I have not circled either of these answers yet, because the truth is only one of them is truly an answer. It's asking, when does the squirrel hit the ground, right? When does the squirrel land? It doesn't make any sense for it to land after negative 0.69 seconds. That doesn't make any sense. That solution is extraneous. It doesn't make sense for the problem. So the answer is 1.63 seconds. Now, if you're interested in as to why we got that answer, well, let me show you. If you were to graph this, watch here. If you were to graph this, the squirrel started off at 18 feet, right? Somewhere up here, and then he jumped, and then he landed here. And this would be the true 1.63 seconds. But the reason we got that negative 0.69 is that if you somehow went back in time, watch this, it would be at negative 0.69 as technically a 0 with the quadratic model. It just isn't in the positive direction that actually makes sense, okay? So always think what makes sense, so that would be 1.63 seconds. So these problems are quite a doozy. The big part of it, though, is just knowing what it's asking for. So refer back to this. Initial height, that's like our y-intercept. The maximum height, we're trying to get the vertex, time it hits the ground. We're trying to find the x-intercepts or the zeros, okay? So that's really all this is. I'm not going to do 2 for you. On number 3, we're talking about if he can throw it. Look at my arm, my finger. If he can throw it high enough. So can he get it up that high? So we're trying to find the vertex on that one. Okay, that's my little hint there. This one's talking about hang time. So in hang time in football, it's like when you punt it and then how long it stays in the air. So we're trying to figure out how long it takes to hit the ground. So that's, you're going to find the roots, the x-intercepts on that one. Okay. So I'm going to let you do all those. Now I'm going to show you one more thing. So like with quadratic functions, we talk about how it's a lot of times used to model objects in flight. Well, you can also sometimes solve geometric problems with it. So like number 5, it's kind of goofy, but this is what it says. Write and solve an equation that could use to determine the length and the width of the rectangle. So you should know this, but to find the area of a rectangle, it's just length times width, right? That's how you find the area of a rectangle. The area of a rectangle is length times width. So if I'm given that the length is 3x and the width is x plus 2, and it gives me the area, I can set up this equation. 3x, and I'm going to write smaller because I think this is going to involve a decent amount of work. 3x times x plus 2 would equal that area of 72. I can set that equation up. And then I got to solve this equation. This gets a little goofy, but here we go. I'm going to distribute. So I'm going to have a 3x squared plus 6x equals 72. To solve quadratic equations, we typically want to set it equal to 0. So I'm going to subtract that 72 over. And that's my equation. So it's set equal to 0. So at this point, I can either factor it, or I can use the quadratic formula. Now, the quadratic formula you might be into, and you can go ahead and use the quadratic formula on this one. That's fine. Numbers might get big. But I'm going to use factoring because it's going to take up less space. And I see a little trick we can do with this one. Because if you notice, all those numbers are divisible by 3. So to make this easy on ourselves, I can factor out a 3. 72 divided by 3 is 24. And now I can just factor that guy. A lot easier. So that's 3 is not really necessary, but I'm going to write it. X multiplies to negative 24, adds to positive 2. That would be positive 6 and negative 4. And then I could set each of those equal to 0. X plus 6 equals 0. X minus 4 equals 0. Subtract 6. X equals negative 6. Add 4. X equals 4. Okay. Yeah. So x could be negative 6. X could be 4. Now just be careful if the problem is what it's really asking you. So, all right. So actually, let me take this a step further. I didn't really think about this too much. Negative 6 doesn't make sense as an answer. Because if you put negative 6 in for x, say here, this would have a length of negative 4. That doesn't make any sense. You can't have a negative 4 length. And then if I put negative 6 in here, 3 times negative 6, that's negative 18. You can't have a negative 18 length. That really doesn't make sense. But 4 does. Because if x is 4, then that means this length is 6 up here. And then this length is 12. Yeah. And 12 times 6 is 72, ain't it? So, yeah, this length here is 12, and this width here is 6. So I think that's really what the question really wants. All right. I'll let you try 6 then. But that's quadratic application problems.